Okay, let's see here. So we want to show that at every point on this curve, we can view y locally as a function of x. Okay, so let me point out that we want to view y as a function. All right, so that means that that's the first thing I need to focus on, is y a function of x. Now, notice that the curve that I'm interested in has been given in the form of an equation, and I've got to fit this equation into a form that that's consistent with how the implicit function theorem works. So the implicit function theorem says I've got to have some function of x and y equaling 0. Well, that's not really how it was given. So the first thing I've got to do is translate that as something equals 0, and I'm just going to take the right hand and move to the left and rewrite this then as 2 x plus y minus sine of x minus y equals 0. So this is my f of x, y. Is that cool? Okay. All right, so I've got, looking at a level set of a function. One of these input variables is what I want to now view as an output variable. So y specifically I want to view as a function. And so I'll arbitrate that question by looking at the partial of f with respect to y, the variable that I want to view as a function. Okay, so take the partial derivative. So partial with respect to y gives, I get 2 minus, now taking the y partial over here, oh, I'm going to kick out another minus sign because of the minus y that's on the inside. So grand total I get plus cosine of x minus y. So that's that partial derivative. Now, what I have to decide is this ever equal to 0? Right? That's the deciding factor. If this is ever equal to 0, wherever this is equal to 0, y can't be viewed as a function. But as long as this is never 0, then y could always be viewed as a function. So good news, this is never 0, because cosine is never smaller than -1, and 2 plus something that small is always greater than 0. So that is never 0. And therefore, y is always locally a function.
So that makes you say that y is locally a function of x?
Mm-hmm. Mm-hmm.
Why is that the case? Yeah.
Okay, that's what the implicit function theorem says. If you go back over here to our single variable implicit function theorem, right here. If you have a curve that's a level set, right? And if the partial of f with respect to y is not 0, then the variable y can be thought of as a function of x locally. Yeah. Mm-hmm. Yeah. Okay. Everybody happy on that one?